So to get a better idea of what's going on with this project and actually see it in operation and explain a few things, I just have decided to do a quick video. Even though the website document explains the project very well, and the code is commented heavily, it may help some other people to just hear exactly what's going on here. So we'll run through the actual code and everything that's going on here first, and then we'll run it and you can see what happens. To explain the windows we have over here, when we get to that point, this window here is the one that we will run the server in, or the script. This window here and this window here are two servers on my network that I have installed the CPU stressor program, or the system stress program, so I can artificially increase the load. So we can actually see what happens when the load goes up and the load goes down, and it triggers an alert and it don't. There are some console logging things still turned on here just for reference. This, like I've said about other pieces of code that are on this site, these are all just to explain how things work. Definitely take the ideas, but don't use this actual code in production. It's not been vetted for production. It's just explanation code. So, of course, up here we load our modules that we need. We need Elasticsearch so we can actually do the queries. We need path because .env needs that, because we use .env to load some settings. In this case, the only settings we're loading are the Elasticsearch connector settings. By the way, this project does still use Elasticsearch 7, the latest version of 7. So it may work with 8, but I have not tested it there yet, so try that at your own risk, but I know it works with 7. As the comments say, these monitoring elements, it's built this way because it's easier to add more monitoring elements in the future. Right now, this is just for system load. This is just a replication of this, so we can access it from inside there, system load. This is the index that we're going to use to do our query. This is the value that we want to alert on. This is, of course, just an integer. It can be changed for anything based on how you're going to key it later, but integers, yes or no, are easier to use here. This is a global for this element, re-alert in milliseconds, 30,000 milliseconds, 30 seconds. As it says, and once you get the first alert, this will alert again after 30 seconds. It's only at 30 seconds for a demonstration. You could change it to 1 hour, 1 day, 1 month, whatever. And if it's still in that condition after 1 month, you would get re-alerted. But only if it is still has been actually in that condition for a month. If the condition resets within that month, then you'll get a new set of alerts and it won't go out that far. This is here for future expansion. Right now it's always true, but you could put logic in to not do auto acknowledge on recovery. And alert type log, again, future expansion. We're not using it right now because everything's being printed to the console log. Here we create an element tracker object. That way, that's what we use to track the status and the pull times and the alert times on all of the different objects. You'll see where we use that more in depth later. This deeply explains what this query is doing. Generally, it is an aggregate bucket query. It gets all of the host names that actually have the load 1 value. Which is here, and these are aggregates inside of that bucket, and these are the 1 minute, 5 minute, and 15 minute load averages for each host that is in the metric beat index. We only actually trigger on this one, system load 1. These are here for informational, so you could craft a message around it, something like system load has been exceeded. It has been this for 1 minute, this for 5 minutes, this for 15 minutes. We don't get that in depth, but I went ahead and left the aggregations here just for information. This size 0 here, unlike the one up here, which I didn't explain, so let's go back to this one. This means I will only at the most look for 50 of these fields. Because of the way this is built with max values, these will be unique. There will only be one one host. No matter how many values there will only be one host, and that's because we're using the max here, which means give me the max value for that host over the time frame that we scan. So there'll only ever be one because there can only be one max value for each host. This size 0 down here is different. Since we're using an aggregate query, we don't really want the actual documents back, but if for some reason you did, you could increase that to how many ever documents you want to see, and you would get those documents back. Along with the aggregates. But generally when you do an aggregates, you don't want the documents too. And then here's the actual query. It's really a bool filter query. And if you read the whole chain, it's query, bool, filter, and then another bool, and then it should match range greater than 0. Should is more sort of like a wild card, but when you're using these kind of integer values, it really don't matter. And this minimum should match covers that because it won't return anything unless there's at least one match. And then of course the range is just how far back you want to look for the data. We look for 1 minute right now. Unless you have massive slowdowns from your hosts that are writing to the metric beat index, 1 minute should be fine, since it does pull every 10 seconds. If you have some kind of a custom use case, say you're only polling once a minute or you're only polling once an hour, you could change this to fit into that. Otherwise, it's only going to go back 1 minute, which works for my small setup, since I don't have a whole lot of things right in the metric beat, but all these things should be adjusted for bigger systems. It's sort of a, your system, what these numbers should be, hopefully. But that's what that's all about. And that's all that is. I mean, it just says, give me the max values for all agent host names in the metric beat index over the last 1 minute. That's all that does. It's the query. I actually built this query in Kibana. I do that pretty frequently. I'll build a visual that's sort of like what I want to see, or a data table, line chart, whatever, and then I'll save it and I'll go pull the aggregate or go pull the query out, and then just make changes where I need to make changes to fit it into whatever project I'm working on. I do that quite frequently. This right now is hard coded to pull every 200 or 2000 milliseconds or every 2 seconds. But really there's no other way to loop the timer. So when this runs, we loop the timer, and that's the good stuff. Where we loop the elements. So the first thing we do is we stop the timer. We don't want another timer launching if for some reason this query gets stuck or this function doesn't finish. So we stop the timer. Again, there's no real error checking on that. There's really not a whole lot of error checking on any of this, but you would have to put in some error checking to say another timer, to say if this timer has been stalled for so many seconds, then figure out why the timer stalled. But this is not that deep yet, so it just stops the timer. Now here we loop through the monitoring elements, which is what we set up here. This may seem a little weird, but doing it this way lets us set different things for different monitors. So say we wanted to do another system load monitor that alerts on 10 and only re-alerts every 3 days, then you would create another one down here called system load 3 days, and you would plug in the proper values here. Then when this loops through it, it would pick up those values for every host. So there, it leaves a little bit of expansion for doing different kinds of polls on different hosts. Since this is the beginning of the poll, we're going to go ahead and set the poll time here. We do that on every loop, even though there may be fluctuations here and there of how long it takes for the queries to come back. It's better to set it here because we'll use it throughout the rest of the script. Run this query builds our query that we're going to send to Elasticsearch using this load query, and plugging in some information from here, like the index, like the index name. So you'll see that down here. Use index and then load query. This load query, actually, the way, since it's just an object, you could swap in and out these values all over the place. right here. Actually, you would do it here under this, and it would be, then you would go run this query dot body dot whatever key up here you wanted to replace, and then follow that tree and replace the value. We don't need to do that here. You know, it's kept this way for simplicity. But like for instance, for one thing you could do here is instead of pulling every document and then looping through them down here to figure out if anything's overload, you could actually just plug that in right here, and it would only pull back documents that are greater than that value. But this was designed to show the if-then tree, so we'll just let it pull everything, and then we'll make the decisions in the if-then tree. Like again, there's a lot of different ways you can go with this to do this kind of thing. This is generally just okay, this is simply how monitoring works. It's just a few if-then statements that says if the data falls inside of your threshold. So this is where we start this, build the query, then we send it to Elasticsearch. We hope we get results. There's really no error checking for that right now. You would do a if results is null, then do this kind of thing and jump out of this loop. But for now, it just assumes we're going to get a result. And this is just to block everything out so we know what we're looking at. Of course, if we were going to run this in any kind of production setup, we would get rid of that. But it'll let us see what's going on when we start the script later. So this here starts the loop through the results from Elasticsearch. I don't like using this as one great big long variable throughout the whole script, so I shorten it here and call it this bucket because it is a bucket as denoted here. And this is really just informational, so you can watch how it works. It'll just tell you what the name of the device that it's currently checking. Here we need a tracker, so we know how many alerts have been sent, what alerts have been sent, if it's the first pull of this device, and a few other things that we need later on. So we just build all this here. It more or less says, if element tracker does not contain this device, then create an element tracker object named this device, and then do the first poll is true because at that point it would be. Needs alert is false because at that point we don't know. The last alert we set at -1. It's just a good holder because the way the math works, it's still going to trigger just fine. And this is alert sent. It's set at 1 because that will be the first thing that we send, and then we'll increment it later. And this here takes all of the information from this monitoring element and it puts it inside there so we can directly access that host. And the reason for doing that is because, like I said, you could have multiple conditions for different hosts, and then they would all be stored inside the key, and they would be accessed from whatever that by whatever that key is. Like I mentioned, if you want to do a different re-alert time, then you would just create system load 2 or something else, and then change this to whatever you want. And then when this runs, it would actually look at it twice based on both conditions. So once that's all done, then we check, as this says, we check to see if the load 1 value for this host is greater than the alert value, which again is something we set inside the element bucket or the element object that I was talking about. So this says if the load value is greater than the alert at value, which is up here, then we need to check and see if this is the first poll, because things are a little different if it is. If this is the first poll, then you get the message console or load threshold exceeded. And you get that message, and then it gives you the alert number, which we increment later on. But right now it's going to be 1 because it's the first element. And then we need to make a few changes to the data for this element, for this host. So then first poll is now false because we already did that. If it needs alert, that's true because we did trigger here on this greater than. And then we need to set the last alert. So the last alert is based on the poll time, which we set up here somewhere. Where did that go? Oh yeah, right there, this poll time. Okay, so we set all that stuff. We've sent the first alert, and it's going to come out on the console log. But here we say, if it's not the first poll, Then we need to do a few other things to see if we need a re-alert and a couple other things. So we also say, yes, this needs an alert because we're inside of this. Yes, the value is greater than the threshold. Then we calculate the re-alert time. This is takes this current poll time, subtracts the last alert from it, which we set here, and we actually set again here. And then it's this here, like I say, is for informational only, which we'll see when we run it. It just shows that the re-alert for this object is not going to happen until re-alert time. So if that is the case, then we get right here and we see, okay, it's time for a re-alert. We increment the alert sent, the alerts sent. We print that as load threshold exceeded, but now it says re-alert notification. And then it gives you the threshold and the other values so you can verify that it's correct. And then it sets the poll time. Okay, so this else down here is outside of this else. So what this else is saying is it goes back up here. So this is if the value is greater than the alert, then do this. But if the value is lower, then we execute what's in here. But we have to make another conditional here, and it says if element tracker this bucket key needs alert equals true. Well, that we set up here. So we only want to do this if it is currently in an alert state, and we keep popping that alert state every time we get here, just so it always stays updated until we get here and we're at a point where the load1.value is no longer larger than the alert value, and then it increments the alert sent, because this would be the final alert. And then, of course, we get the message that says the load threshold has returned to normal, this bucket key, and all that, an alert cleared threshold, and then the number. And then it takes us back to needs alert equals false. That way this won't get triggered again until this gets triggered again. And then alert sent gets set back to 1. When we're done with all of this, then we restart the loop timer on a 2-second. Again, with a loop timer, you could do a bunch of calculations to figure out how long it took this to run, and then you could subtract that from the loop time, and then you would actually run it again on a pretty close to a 2-second cycle, because this may actually take more than 3 or 4 seconds to complete. But again, this is an example of just a quick flow of how this works. So we'll just restart it with a 2-second, and then again we stop it again up here when the loop runs again, because we don't want it to. We don't want multiple loops to start running at the same time, because with JavaScript that could happen. So then that is done. There's no return because everything happens inside here, and then everything goes again. So now we're actually going to watch it run. So when I run it, with the load of 1, alert at 1 right here, it's not going to alert on anything until it's at 1, but it will tell you what it's trying to look at. So let's run this, and you'll see it right here. So now you see it's checking those hosts, but there's nothing to alert on because there's nothing that's none of my servers are at a load higher than 1 right now. But what I'm going to do is I'm going to go to this one called Star Cache, and I'm going to run the system stressor that you can download that you can install with apt-get. And it shouldn't be too long before we see the server Star Cache throw an alert over here in this in the server window, or in the script window. What you got to think about is after I start this, it takes a little bit of time for the load to ramp above 1. And then it takes a little bit more time for the data to get from that server to the server, or to the script, or to Elasticsearch, and then read it back out by the script. So you can see here that we got this error. The load threshold exceeded Star Cache first notification. Threshold is 1, value was 1.78, and this is alert number 1. And then it starts counting down when it's going to send another alert. So you'll see here in a few seconds that it will send another alert. And there it is. And the load is currently at 4.23. So let me stop this so the load can start coming back down, because that also takes a few minutes for the system to calculate the load down. But while that's calculating down, we're going to go ahead and set it off on, or do it on another server called Observability Project. Same thing, except it'll ramp up a little bit slower because I'm using 4 CPUs instead of 8. So we'll start this. And so Starcache just got re-alerted. You can see that right there. But at this point now, it's going to alert again. Now, again, like I said, it takes a while for the system to calculate that load back down. So we may see that re-alert a handful of times before it finally clears. So now we have exceeded the load on the observability project, which is this one here where we just started the stress test, alert number 1. And you can see it runs these individually. So Starcache can get an alert out of band with observability project. It's just built that way. So you may get a re-alert, like it says here. We'll get a re-alert on observability project in 10 seconds, but we won't get another alert on Starcache until, well, now at this point, 10 seconds. So we got the re-alert on observability project, and Starcache, see, the value's still dropping, but it's still not below 1 yet, and that's what we're waiting for. Now, again, this has happened. This is pulling every 2 seconds, and the re-alerts are happening every 30 seconds, but that's all controlled by this number right here. You could set it, or 30,000 milliseconds, 30 seconds. You could set it for 60, for a minute. It doesn't matter. As long as the script runs and the timers keep updating, you could set it for whatever number you wanted to. And that's the cycle that it would alert on. But for this video, it's better to do it in 30-second cycles. That way we can see what's happening. So we can see that Starcache is still dropping somewhat, still not below 1 yet. Observability project, we're still running the tests, so the load number will be pretty high when we get another re-alert on that. And like I've mentioned through, we're at 3.42, so yeah, we're up there a little bit. Okay, so now this is what I was waiting for. Starcache returned to normal. So the load threshold, actually, where did that one go? I gotta find it. Where did it go? Yeah, load. That was the re-alert on Starcache. Okay, let me go ahead and stop the observability one, and we'll watch it flow through too. Where did the one for Starcache go? It's a problem when you're running things every 2 seconds. So up here, see here, Starcache was still a problem. It was still a problem there. It was still a problem there. Yeah, here it is. Load threshold has returned to normal for Starcache. Alert clear notification, threshold 1, value 0.93, alert number 7. So it pretty much did exactly what I wanted it to. So, but now that we're not running multiple overloads at the same time, we'll see what happens when this one comes back down. When observability project comes back down. But as you can see, it's working. And like I said, everywhere it triggers one of these console log messages, the alert or the re-alert, see, that's where you plug in your logic of, okay, what do I want to do when this goes into alert? What do I want to do if this gets re-alerted 1 time? What do I want to do if this gets re-alerted 4 times? And you could call functions to send mail, send data over a TCP socket. You could have it launch a script to do something else. What you can do is unlimited. The point of this whole thing was just that this is simply what it does. It'll monitor for this. It'll monitor for this value, and trigger. Based on those values, it'll do whatever these different things are. That's simply what monitoring a data stream is. You're looking for something to happen on a condition that you set, and then you tell it what to do after that condition is hit, and you can tell it what to do after that condition is cleared. You can tell it what to do after it has to be alerted 4 times, 5 times, 10 times. It doesn't matter. It's all limited by what exactly you want it to do, and this, in the end, this is how simple it is. It's just a loop that says, if this is the case, do this, else if this is the case, do this. That's all it is. Like I mentioned in the post, the complexities come from the things that you wrap around it that you want it to do after that alert happens. Otherwise, this is all it is. So hopefully this will help some people understand what I got going on here, and that, monitoring a data stream is not difficult. It's the things that you want it to do after you hit your threshold that can become difficult. And before I close this video, we can see that now observability project has returned to normal. It was alert number 10, and it went below the threshold of 1 with a value of 0.97. And that's pretty much it. If you got any questions, hit me up on links or with comments or questions wherever I post this, whatever social media. It'll probably end up on LinkedIn, maybe Twitter. So anyway, that's it. That's how I show this is quite a simple thing. And don't try to think it's more complicated than it is when you go in to start working on things like this. Thanks. Bye.